to use a radar altimetry data, and it's compatible to data products up to Sentinel-3. It's available for Windows, Mac, and Linux. Regarding the online availability of the processor, usually you can download the processor at this link. At present, due to some technical difficulties that we are having, the toolbox can be downloaded from the ESA link reported here using this password. To easily access on your side, in the poster you'll find in the poster session, there is a section including a QR code with a password, and you can just scan the QR code with your mobile phone to access and bookmark the page for a later download. Along with the code, you find also an Altimetry tutorial, including some of the material I will be presenting today, and also some Altimetry fundamentals discussed in the first part of this training. Then it's available also a YouTube channel for BRAT. You can find also exercises and other videos discussing the various possibilities of the toolbox. More can be found, of course, in the user manual of BRAT. Now I'll discuss the graphical user interface, the various sections of the software, and then I'll provide you some videos showing how you can use BRAT for some simple exercises to clarify what we have seen and said this morning. The graphical user interface is quite clean and allows you to firstly to create a workspace by using this button here. Please create a workspace every time you start a new analysis, as you can imagine, a workspace includes options, preferences, and so on. So once created and saved, you can access the software as is now. So you have a datasets tab, a filters tab, and operations that will be discussed here. At present, we will not be discussing the access to the RADS datasets. I'm not sure if this is still available, but we could check it later. And running BRAT is basically a three-step process. So you have to select your data sets. You can include filters to focus the attention on a specific geographical location. And then you can perform operations. In particular, these operations can be of two types, quick or advanced. Quicks are operations that are predefined, and advanced operations, thanks to the BRAT interface, you can write formulas. And so advanced operation may include every equation you want using the fields available in the NetCDF product that you will open in BRAT. The first thing is a very minor point. It's about changing the map layer in BRAT. You can access using tool options, and you can select, for instance, one of these two maps. You select, you close, and you simply save the preferences in the workspace. And once you reopen BRAT, the map will be displayed. The first exercise I'm showing here is about showing you the MMB waveforms, which are reported in this JSON2 SGDR products, to investigate the waveform contamination in the coastal zone. So the idea is to open the product, show you the fields in the product, then and show you an animation of the waveforms, the MMB waveforms, LRM, because we are talking about JSON2, the way they evolve in approaching the coast from the open ocean. So you will see firstly very clean waveforms, and then the contamination will appear. As a reminder, we are working with these LRM waveforms now. Again, remember this slide for the comparison in terms of resolution between SAR and LRM. We are working with the red footprint here. So along track and across track, we'll have a resolution of from 2 to 17 kilometers, dependent on the significant wave height. And again, this is the SAR case. For now, we focus on this because we are working with LRM waveforms. And so the idea is to check that the waveforms here are clean, and then contamination appears in the proximity of the coast. I launched the video. I hope everything will go well, as sometimes PowerPoint creates problem. But basically, we open a data set. All the material of this training will be available online, so don't worry if you miss some of the procedure. I just imported an SCDF file here. You have the global description of the product, the provider, then various information about the ellipsoid, the processing center, and some auxiliary data that sometimes can be useful, but this is mostly information for very expert users. The other field of interest for you is what is reported in this second window with all the fields, all the variables that you may find, like the altimeter, like the retracking estimates, like the ellipsoid parameters, like the quality flags associated with the retracking estimates, the geophysical correction from the ionosphere, the troposphere, and also the peakiness we discussed before. Then, for instance, quality flags again, the range estimates, C-state bias corrections, sigma 0, C-surface height anomaly, and in the end, we will reach also the significant width height and the waveforms that we want to plot here, 20 Hz KU and C-band. So we focus the attention on this KU band for now, and you can see that when you load your product, you have the track displayed on the Brad GUI. By accessing the filters tab, you can create a filter, a bounding box that will allow you selecting just a portion of the track. In this case, we are studying a coastal zone, so the filter will be small enough to include just the open ocean and then a coastal zone. You select the latitude and longitude limits, then you activate the filter in this other area, and it's possible also to import KML files in BRAT. It's not done in this training, but it's a thing you can do, and you can check the user manual to have more information about this. So once filtered, the track, the section that you will process will appear in yellow. Now we move to the operations, and to create an operation, we simply access this advanced tab here, because we don't want to do a predefined operation. And then we put the latitude in one field, and in the data we put the waveforms. So the idea is to plot the waveforms in approaching the coast. The filter has to be activated again here. And so the section will be here. We are moving northwards, so we are crossing first this, we are analyzing the results in this open ocean area, and then we move to the coastal zone here. It's pretty fast in processing the data once you click on execute, because the track section is very small. For displaying the waveform, so you have to modify the dimension of the plot in this way. Not very important to focus on this, modify the scale and zoom properly, but in a moment you will see the R1B waveforms correctly displayed. And I'm sorry if you see latitude here instead of 128 beans, but there is probably some issue with the software in manipulating this data. It's modifying the dimension of observation of this matrix, including the R1B waveforms. So there is probably some small bug. But in any case, this is what you have. We are starting from the open ocean, and so you have again noise, leading edge for the estimates, and then you have the trailing edge with some obvious noise due to the real case. So far, we just seen theoretical waveforms. And BRAT, using this data, allows us to run a video, like playing on visualizing the records one after the other in a video, in order to show you what happens when we approach the coast from the ocean. You will see different waveforms, slightly different sea states, as you can imagine. Of course, from a record to the other, with a posting rate of 300 meters, 20 Hz, you don't expect the sea state to change so much, but you can see that if I move now to the coastal zone domain, the waveform starts becoming more contaminated. The noise plateau is no more flat. The leading edge is impacted. And then you see contamination also impacting this area. And this is a waveform acquired here. If we go even further, we will have our satellite crossing the land, and so the footprint will be even more contaminated. So I'm just modifying the frame record number to move ahead, and now go to the land case. And from the previous waveform, the extraction of the results was already pretty difficult. This one is actually not including probably any water level information. So it's just an unusable waveform carrying no information. And this is the first video, the first example on how to check your data. Important point is that you think that you can take sometimes the L2 estimates and use them as the ERN products. I suggest you to always have a look at the R1B waveforms associated with them, because it's important that you understand the scenario, the eventual contamination, and not only rely on what reported in products in the estimation. So it's important to understand how to filter the data and how to use the peakiness mismatchiness, the misfit, and all the parameters that you might get from the data to understand how to correctly filter the data. So now we have seen the tracking estimates, and we are also having a look at how BRAT can display the sea surface height, for instance, from JSON2 products. Again, I remind you the construction of the waveform. I remind you that the retracker, in terms of physical retracking, is made by a fitting between the altimeter signal and a population of model until the best fitting model is found and the three parameters related to the sea state are provided in the output. This is quite important because so far we have seen the contamination of the waveforms and we discussed the ELSE plus the tracker. No? We will not see the ELSE output in BRAT, but this slide is reported here again just to understand that in approaching the coast, the LRM SGDR JSON products are contaminated. And so what you will see in the BRAT exercise is exactly what you see here. So in the JSON product will be very reliable in the open ocean, and then in approaching the coast, you will see that the sea level height anomaly will increase a lot. And will be something which is contaminated by land and so not reliable. It should be considered an outlier. But to make this, you want to perform some validation with in situ data. The same product is used, so no problem in just continuing using the products we already opened. We just change the operation, selecting latitude this time, and including the outputs from two retrackers. One is the standard one, and the other one is the MLE4, I think, which had in the past the possibility of estimating some other parameter, considering the MLE3, considering also the antenna pointing and its relation to the trailing edge. In any case, the importance is to see how to perform this operation. So you can have this field of data in which you include as many fields as you want to have one curve, two curves, three curves, all the one you want. You can select every time, revise if you want the units of measurement, and then you simply plot your data considering the filtering we used in the past. And once displayed, this is the open ocean, this is the coastal zone. You can revise the colors, and what you can see is what I was anticipating in the slide with ELSE. Essentially, here we are with our processing in the open ocean, the estimates in the open ocean. Sea surface height anomaly means that the sea surface height corrected is the altitude minus the range. An anomaly is this value minus the mean sea surface. The mean sea surface is considered a reference. Everything which drifts from it is an anomaly. And so that's why this level anomaly is very important to understand if you want to understand the specific behavior of the sea level in specific cases. In cases, for instance, in which you have an extreme event like a typhoon, the sea level anomaly in that track will vary if compared to a sea level anomaly acquired, for instance, in the case of Sentinel-T, 20 days before it, and so it's important also to have a knowledge of the fields that you can use. This level anomaly reported here indicates that the tracker provide similar estimates in the open ocean, and then in approaching the coast, you see that there is an abrupt variation in the tracker estimates, and this is because we are approaching the coast, so the land contamination is present, and you cannot trust probably these waveforms. To tell more, you could use validation, you could use the quality flex. And in the case you would have, for instance, you want to study the open ocean and you have reliable data to check which tracker is the best, you could perform an analysis of validation like those I showed at the end of the first presentation, to understand which retracker performed the best. And so this is just to let you understand how it works in the coastal zone again with contamination, and to show you how you can perform, how you can display the results in BRAT from two different fields present in an SDF files associated with JSON2. A thing that I want to say is that this continues pointing out the same thing I was saying, is that the outputs of BRAT are saved in the workspace folder. You will have a netcdf file including all the fields you have included in your operations, and it's also possible to perform statistics, which is a thing we will see now in this other exercise. And what you want to do is just to close, every time you want to start a new operation, you have to close the window, the final window of the previous operation. And then to make estimates in terms of statistics of, for instance, the significant weight height, this level height anomaly, you just have to press this other button here. And it will take the input vectors, providing for each vector the mean, the standard deviation, the minimum and maximum value. And so very easy, and this will be saved in a txt file. So the vectors will be saved in an etcdf file, and the statistics will be saved in a txt file in your workspace folder. And this is very nice because in the next exercises, I will show you how we could study, for instance, the sea level in a specific region, and we will take the outputs of the fields and also the statistics. So I can proceed showing you now the importance of applying the geophysical correction. In the first slide of the first training, I showed you this figure. Now the idea is to evaluate the sea surface height anomaly, including a range which is not corrected at all by the propagation corrections and the surface corrections, and then compare to a product which is fully corrected as it should be in your analysis. So again, same track, we consider the same area. And then the idea of beneath this exercise is just to let you understand how to create formulas in brackets. So you can insert an expression using this other menu here. And it will be about altitude minus a range to create the sea surface height. And so you have, of course, to insert the parameters as named in this fields formula. If not, you will end up having errors. Then you subtract by the mean sea surface to have the anomaly. You check with this button the correctness of the formulation you have written, and then you save the expression with this other button. So you write, you check, and you save. Once saved, you can, for instance, rename your expression sea level anomaly, no corrections, and then you can change the units here. Okay, and I think that the video now will show, I think, some information about the fields that have been inserted. You see the name is exactly the same. And most importantly, the range that you want to check here is a range including these instrumental corrections. And so that's why it's very important not to start doing just the exercises, putting the formulas, and you have to understand the products and check the comments associated with each variable to understand the corrections that have been used to produce this provided field. And this is very important, especially when you're running analysis and evaluating the sea level, because if some corrections maybe are not reliable in specific areas, this wrong correction will have an impact on your analysis. So it's very important to have the full control of what you're using. Now I add a formula to add the same quantity, but this time corrected by the ionosphere. And so I change the name again, I change the units, and then instead of rewriting the formula, I can make a simple copy and paste, and then add the ionospheric correction of interest for this specific formula. And here it is for the ionosphere. And again, I have to carefully check the parentheses. And once done, I have to check the data expression for its correctness, as it is now, the expression okay, and then I can save the formula. Of course, the sense of the exercise is clarified. I think I will add, it's clear I will add all the other corrections. So we can skip just to the results. And in this figure, you see the final output, the plotting of all the various fields. In black, you see the non-corrected one here, and you see the impact of the various corrections. Here I just applied, for instance, the impact of the iono correction is pretty small. Then you have something more which is related to the WTC, the wet tropospheric correction improves further. And then when you apply all the corrections, you reach the value of the field given in the products, the sea surface height anomaly, which is with fully corrected range values. and you see that the difference is around 2.5 meters. And so you see the error that you make in the evaluation of the sea surface height if you don't correctly apply all the corrections, and the impact is huge. Again, it's very important to be sure that the corrections you inject in the product are correct. Sometimes we had projects in which the coastal zone sea level had a certain trend, and we later understood that there were issues in the corrections or in the managing of the corrections. So it's very important that you have full control on the data you are using. And this is why applying the whole set of corrections results is clearly the same in the end. But here it's by including the dry tropospheric correction and those related to the sea state. This is an exercise using L3 products, and these are something more specific. They can be downloaded from this Copernicus Marine Service website. L3 products and L4 products are upper level products produced as follows. So for the L3 products, we have products produced by using many missions. So these are multi-mission products in which we just consider the difference in all the missions, and we just correct for the various biases that might be present, that are present for sure. And we use the same set of corrections. So we shall guarantee homogeneity in the corrections that we are using in order for the user to have this as a unique data set provided with the same corrections with all the biases corrected. And here it's a global data set starting from this year and including these missions. You can see the description, you can see also the ellipsoid, the format and so on, producer and so on, the resolution, the end date and the file name. So now Brat is able opening these files, and we will open all the data available for 1 month. For a few of these missions, DL3 is not merging the missions, it's just homogenizing them and keeping them separated. So when you use the folder, when you open the folder and you see the products, you will see that you have, for instance, in the file naming, global AL is ALTK, L3 product, mission, the date is for January 2015. Then you will have Cryosat2, for instance, here. And the other missions I considered is iYoung2, and then another one is JSON2. So now we are injecting these L3 products, long track products, and it will take some time because the data set is quite extended, so it will take some time. I will just show you the output, which is, sorry, probably I moved too fast. Here is the finishing of the loading, and when it finishes, you have all the tracks reported and displayed on the map. Now, as we made in the other exercises, we can display an area of interest. And this can be done as made before by selecting just, for instance, I think it was the Mediterranean Sea. Okay, so you see that there is no need also to insert the numbers. You can simply design on the map your bounding box, and the values will be given immediately. And then you can just confirm the area of interest. This was the one we used in the past, so something that you can delete, and you can stick with the new created area. Now we can proceed and create operations. It's clear that when these reprocessings are done, creating these L3 and L4 products, you find only specific variables and not the full L2 data fields that we have seen in native JSON products, the one we showed previously. And so the number of fields is very reduced if you see the excursion of this bar. And we want to create an advanced operation, and select a couple of fields. I think it was with this level anomaly and the absolute dynamic topography. In this case, we create a map, not a single graphic as before. We use the latitude and the longitude. We select the data, the SLA filtered. And another possibility is to check also the ADT, the absolute dynamic topography. We use both to create these two graphs. Everything is set. We have just to confirm the area of interest which we created with a filter, and then we can process the data. And with split plots, you can obtain separated plots. So this is another option. Now, by moving forward, you have to confirm, and then the processing will start. Of course, it will take some time because the data are a few. And I can move forward. Okay, so let's point that this is the first display, I think, about the sea level anomaly. You can see it's in the region of interest, it's on a map this time, and then we move to the ADT. Okay, sea level anomaly filter, as said, you see the color bar. Of course, you can manage all the values of the color bar selecting the extremes of the interval of the color bar. And this is the ADT. And the color bar values can be changed like this. So it's important that we are studying just 1 month of data. So the idea is to later is to repeat this exercise by using whole months, keeping the color bar interval the same for all cases in order to have the excursion, the variation of ADT and sea level anomaly during all the months, during all the whole year. And the color bar can be changed to your preference. And another nice thing that I think will be showed in a second is the possibility to save the images. But by using uh, button here, you can change the format, and this will be saved in your output directory. And another thing is that you can also visualize the results on a globe, similar to Google Earth, not exactly the same, but at least you can have an idea. And this is another possibility. So now what I want to do is also to evaluate the statistics for this region, and I will end having the mean sea level anomaly for this area in the month of January, as I collected all the input data for January from this repository of healthy products. And so it will take time. I will end up having some output products, including the statistics here. Here are the statistics of ADT and sea level anomaly, again, the mean, the standard deviation, the minimum and maximum. So the idea now is that if you want to make some nice animation about the sea level variation in your area of interest, for instance, now we change and we go to Eastern China, what you can do is that you can repeat the exercise collecting all the products for each month, January, February, and so on. You launch 12 runs as showed. For each you save the image, you save the statistics, keeping in mind that you have to maintain the same color bar in each of the 12 figures. And then what you can end up is to just create a video like this one that is typical of maybe sometimes you watch YouTube videos dealing with climate change and you have maps animating in a similar way. And so it's something that with some workarounds like saving clearing statistics can be created also easily by you without involving the use of more advanced softwares like Python, MATLAB, R, and so on. Of course, the color bar should be kept aside and can be, I saved it, but that's the understanding of what I wanted to show you. And you can evaluate the annual variation of sea level in this area of interest. And of course, you can add your color bar in the results. Importantly, if you consider the statistics and you take the mean value for each month, you can also have the interannual variation of sea level anomaly and absolute dynamic topography. And this can be obtained very easily with BRAT, so if you want to perform some exercises, uh, it's fully doable. Regarding the L4 products, I will not do an exercise, but you can have a look on the Siemens website, and these are gridded products, not long track products as those we have showed in BRAT. Now, last exercise before moving to discuss the new GPod, which is the Earth console. I left GPod here because, as in recent papers, we still see the name GPod inside. Please make sure to correct this mistake because now from GPod we have all the processors, Salvatore family, in another platform named Air Console Altimetry Virtual Lab. So we studied an effect like a typhoon named Typhoon Maria using data from a GPod. I will explain better what Salvatore processors are in the next part of the talk. But imagine that you have another repository of data and you can process selected data. You can select Sentinel-3, for instance, data in your area of interest over an interface. Then you can select processing options at L1B, SAR mode, and at L2, retrackers. So you see the Samosa retracker here. And then you can obtain output products to perform your analysis. In case of Typhoon Maria, we wanted studying this typhoon that happened a few years ago in eastern China. So this is the intensity line of the typhoon from the very beginning up to the end. And the nice thing is that over Sentinel-3 we have not only SLAL, the altimeter, as part of the payload, but also OLCI, which is an imager, medium resolution imager. And the nice thing is that you can simply check for the dates over which you had the typhoon, go to the ESA website and check for OLCI data, check the quick looks that can be accessed in a second. And if you see a typhoon, the nice thing is that your radar altimeter will be on the same area. Then you have to check if the track is crossing the typhoon exactly or not. This can be done in Salvatore thanks to the output KML provided file, or by using the Sentinel-3 tracks I showed in green and red in the first presentation. In this case, we were lucky because Sentinel-3 was crossing the typhoon. And so it's nice now to verify what I said at the very beginning, that the significant weight height in case of a typhoon will get to very, very high values. Essentially what we do is to compare the case of typhoon with a track acquired 27 days before the event, so in case of no presence of a typhoon, just to let you understand the difference of an extreme event on your altimetry products. The product is opened. This was a GBot product. Now the same would be provided in the Earth console Altimetry Virtual Lab. I'm not discussing the fields because actually they are more or less the same of those you find in official products. And we can move to the evaluation of the estimates. Of course, you will see operations regarding the plotting of significant weight height, sigma zero, sea level anomaly, and I think the amplitude also is reported. There is no need to waste time on this, and I show you just the operation. So the latitude is just evaluated, the starting point to evaluate the sea level, the significant weight height, the wind speed, the sigma zero amplitude, and the sea level anomaly. And we see what happens in case of a typhoon now. So this is the first plot with the significant weight height, the sea level anomaly. Sea level anomaly at 20 Hz, and the typhoon was located at these latitudes. And you see the variation due to the typhoon in comparison to areas not impacted by the typhoon. So the impact is clear. There is an anomaly in the products, which is due to this extreme event. Now we move to the next. I change simply the color bar here, the color value, and then you see here the significant weight height, again, same portion of latitude, and you see the value it gets between 10 and 20 meters, which is typical for these extreme events. In other areas, which are open ocean or anyway not impacted by the typhoon, the value is way lower, and you see that in approaching the typhoon, the sea level also increases. Then with this is the sigma zero, the amplitude. So when we have a significant roughness of the sea, the power will be backscattered in many directions. Even if we are using SAR, we will waste some power, it's clear, because we are not integrating like the fully focused SAR. And so the power value in this case will be way lower, because it cannot be compared to a coherent scattering from a flat surface. So you will see later that this power will increase. Now it's very low in the area of the typhoon. And the last observation is about the wind speed, which in case of a typhoon is very high, because the significant wave height is very rough, and this is dictated by a strong wind, which impacts the surface of the sea because of the typhoon. Okay, so now we move to the other product in which we consider a truck acquired, a product acquired 1 month before the typhoon. So there will be no issues in terms of sea level anomaly. You will see that there is no abrupt variation as in the past. The sea level anomaly is there. It's not enlarged. Then you have the wind speed, which is now significantly lower than before. Then you have the significant wave height, which was before between 20 and 10 and 20 meters. Now it's very low, below 3 meters. So actually you see the difference. And then the last is about the sigma zero, which is higher than before. Before it was around 5, I think it was. Now it's way higher because the surface is flat, and so a more coherent scattering phenomena power is received. And this is it. Now we stop with the Brat toolbox, and we start with the Air Console Altimetry Virtual Lab replacing GPod. So please don't publish papers reporting in GPod anymore, because this is obsolete. We moved to this new platform. I will be running a video now, and then we are discussing a bit more in detail the processors. So the nice addition is that now you can also ask for a virtual machine, deliver your apps using this mature system, very powerful, and then also deliver your processor to Air Console if you want the processor to be installed and made available to the whole community. I think that is important to underline is that while the previous GPod services were free for everybody, now you have to go to the network of resources. So basically you have to indicate your usage of the platforms, indicate the amount of time, the hours of processing. A quotation will be provided to you. This can be partially covered with a sponsorship, and then your access to the processors will be granted, and you can start processing the data. So it's not free anymore, for obvious reason, because it was not possible to just satisfy all the researchers with these huge processing campaigns that were requested, and so the paradigm has been changed now. Anyway, to add some details, the Air Console Altimetry Virtual Lab, founded by ESA, aims at providing a virtual space to support the altimetry community in the development and operation of new Earth observation applications and foster collaboration by leveraging on knowledge-sharing tools. The Altimetry Virtual Lab has been developed on the new Air Console platform and hosts the Salvatore family of processor, which was previously available on the ESA GPod environment. And this Altimetry Virtual Lab ensures the service continuity following the recent termination of the GPod environment. The driving concept is to offer the same processing capabilities formerly available on GPod while improving the user experience by combining the access to innovative, fully customizable Altimetry data processing services from a single environment at the push of a button. So you don't have to download anything on your computer. All the data will be taken from fast access service by their console systems, process the data, and the data will be delivered to you or to your personal FTP. And then the ability of Assetto tools to network with colleagues. This is also provided to keep up with the latest news and publication on radar altimetry. And also we IMAT allow you to share your results to avoid the duplication of the efforts. There is a data repository where which the saved data can be stored. And if you want to make it available also to other users. And then the nice thing is that we are offering a virtual space which is very flexible and can be further reshaped following future emerging needs of the community. Regarding the processors available. So firstly, the Gbox service, so you can request, you can access not all the Altimetry processors available installed on a console Altimetry Virtual Lab, but you can also ask for a Gbox service in which a virtual machine can be given to you for the development of algorithms, for testing them, and also for post-processing analysis. To ease the task, we are also providing broad panoply and Python on these virtual machines. Regarding the ready-to-use processors, part of this Salvatore family, we have the ELS plus R tracker provided by Tio Munchen, Marcello Passaro, as discussed before, but in the flavor valid for SAR in this case, an empirical tracker which is very fast. Then we have the fully focused R for Cryosat 2 and Sentinel-3 developed by Aresis using this fast formulation indicated before by Samira, the Omega K. Soon this will be extended at least for the coastal and inland water domain to Sentinel-6 data. Sarimbatore for Cryosat 2 and Salvatore for Cryosat 2 for the Cryosat mission are available, and also Salvatore for Sentinel-3 are available as well. So we have the full set of the Salvatore family for Cryosat 2 and Sentinel-3. Then we have the 2 SAR processors developed by the University of Bonn, and also to be open soon, this MAP FFSAR fully focused processor developed by CLS. We are still ending the validation phase for this, but it will be soon opened. All the processor can be requested for bulk processing or on-demand processing. Bulk, if you want to process a significant amount of data, there is no need for you to access just the service on your own. You just ask, providing the list of products or the time period to be processed. Provide this information to the console team, indicating the processing options that you want to apply. The processing will be done and the products will be delivered to you. On demand, it means that you access the platform on your own. If you want maybe to start testing the outputs on a few tracks, and so there is in that case no need to perform a bulk processing, but it's just on your side to understand if the processing options are correctly set. Then you can also request to integrate through the IAP service additional processor, and you can also, as I said, access a set of tools to network and share information and results with colleagues, which means we provide a forum, a dataset repository, and a knowledge base section with publications and media for consultation. More information can be found in this brochure, indicating all the procedures to access and use the services, and in the poster we are presenting. In particular, you will find also here a QR code. You can see here the QR code to download directly the brochure. So it's like made to ease the task of also searching for this information. The processor presents some information of all the processors in the poster presents some information of all the processors in the Salvatore family. Now, a quick overview. Once you have your access has been granted, you will be directed to a mosaic in which you can check for all the available processors. And then when you click on it, on one of these, you will be directed to a graphical user interface, allowing you to select the products, the options, and then launch and submit the processing. I think that will redirect you to your personal area, in which you can follow the status if the processing has been successful and finished, if it is ongoing, if it has failed. To say it more with some more detail, you select with a bounding box the track of interest. Probably in the future we will allow also the injection of a shapefile to maybe allow you tailoring the processing better for coastal areas or for the inland water domain. select the tracks that you want to process, select the A1B and L2 options, and then submit the processing. Of course, you can check the software user manuals associated with this tool in order to understand all the processing options available in our processors. In particular, the list of processing options spans from several options related to both the posting rate and to the possibility of improve, as also indicated by Samira, the quality of the products by applying, for instance, the Amin network. The FFT0 padding also is very useful to reconstruct the I1B waveforms with more point, and so to improve the quality of the subsequent retracking. In particular, as non-experts could have difficulties in selecting this significant amount of processing options, we decided to introduce this menu pick profile, which allows you to select to have the system selecting for you the processing options. So it means that if you want to replicate the official Sentinel-3 baseline, you click on this and the processing options will be set to match the official Sentinel-3 ground segment processing methodology. If you want to process data with the Dylan Water profile, you select this and the processing options will change. In particular, if you use the HPR, high posting rate, the variation between the two will be a posting rate taken to 80 Hz. So the spacing will not be 300 meters, as I said, but 80 meters, which is very useful if you're studying rivers and inland water bodies of a short extent. In particular, the FFT0 padding increases the number of samples, and so you can reconstruct your waveform. Here it's very peaky. High peakiness means that we are over a lake here probably. And so clearly the waveform shape is different, and we will need retrackers for the inland water domain. This is an extended receiving window. This is another processing options, which is very useful when you have scenarios which backscatter for a significant amount of range gates. This is not the case for the typical operation waveform, in which the typical range gates are enough probably. But in scenarios in which you have a significant clutter, or you want to study the echoes coming from different parts of the scenario, I said this because we had a project named Albiom, Altimetry for Biomass, in which we studied the altimeter signal over forests, so with trees, trunks, leaves, and also the soil to be reached. And in this project, the extended receiving window offered by the Salvatore processors was considered very useful because it was able to include all the backscattering, and so allowed them to perform their research. The 80 Hz posting rate can be seen here. Here in red, you see the typical data 20 Hz, and the 80 Hz spacing is in black. And so you see you have many more points, final posting rate, allowing you to perform a better analysis, more robust by the statistical point of view, as some points could be, of course, contaminated by the land. In particular, the Amin weighting, as indicated by Samira, you imagine that we have these beams in which we make the SAR processing. Every time we have a beam, we have a main lobe and side lobes, from which we can get also contamination coming from these directions. Okay, and this, if you apply this consideration and you avoid using the Amin weighting, in a red diagram, you will see the difference. Essentially, this is the case in which we stick with the normal processing, not applying the Hamming. When we apply the Hamming, the contamination you see is way reduced. The cardinal point, of course, is this one. And if you see this replicated for the whole red diagram, without Hamming, you have this result full of contamination and from side lobes, and with Hamming you have a much cleaner result. So that's why it's important to use Hamming every time you have to deal with contamination in this scenario, specifically in the coastal zone, in the inland water domain, but also icy region are very important. Results can be improved by using the Hamming weighting. Regarding the list of processing options at level 2, here we provide to the users the whole Samosa family, which is Samosa 2, used as a retracker on Sentinel-3. And then we have Samosa 3, which is a sort of simplification of Samosa 2. So probably you want to use Samosa 2 directly. Then we have Samosa Plus and Samosa Plus Plus, which have been developed to manage lossy states. So significant weight heights between 0 and 2. are better managed in the coastal zone, but also in the water domain if you use Samosa Plus and Samosa Plus Plus. Then, to say you something about these two retrackers, with Samosa 2, you can better manage waveforms acquired in the open ocean. So the typical shape we have studied in this first part of the training. When you move to the coastal zone, but in particular also to the inland water domain, in which the waveforms can be very peaky because of significant wave height values which are very low, the the retracking model, considering just this evolution of the model is no more valid. You cannot fit with a model in red a waveforms like this. And so you need another model which makes use of the mean square slope to better fit these high peaky and specular returns from inland water domain or coastal areas. And that's why there was the need of developing the Samosa Plus and Samosa Plus Plus models. And then, thanks to the activity performed in the ESA Baltic Plus CL project, the ELS Plus SAR has been developed by Marcello Passano. It's an empirical retracker. Being empirical, it cannot estimate a physical value of significant wave height and sigma 0, for which we need the fitting of the waveform. But the nice thing is that it's the first retracker including a assisted bias model, which is computed specifically for this retracker. In other cases, you have assisted bias model derived from other missions and then reused, for instance, in Sentinel-3. So in ELS Plus, we have not only the estimate of the sea surface height, but we also have a correction of sea state bias. And this is very important because there has been a lot of discussion around the sea state bias correction in the altimetry community in the recent years. Here, as promised, I show you a comparison between Samosa Plus against ELS Plus R. This was made for the Baltic Plus CL project, and we include also the tide gauge data. As the reference datum of the tide gauge was different from the one used in the altimetry mission, this is Sentinel-3, same L1B waveforms, just the two different retrackers applied, okay? So the starting start point is the same, and we use Samosa Plus in one case and ELS Plus R in the other. You can see that the results are pretty much aligned, evaluated around 0 because we have demeaned both trends, being the datums of tide gauge and altimetry data different. The R is the correlation, the closest to 1 the better, and the RMSE is the errors, the closest to 0 the better. Here you see no significant result, no significant difference between the two, and so the results are pretty good for both retrackers. Specifically, as ELS Plus R was considered, we wanted to demonstrate that ELS Plus R was better in dealing coastal contamination. We derived this analysis in 3 areas: distance to the coast between 10 and 15 kilometers, distance to the coast between 5 and 10 kilometers, and distance to the coast between 0 and 5 kilometers. In this case, on the right, we show results without applying the misfit filtering, which was an indication of the good fit of the retracker, telling us if the retracker was correctly operating the fitting to the altimetry waveform. And in another case, we apply the fitting. As you can see, the results are very good in both cases. We just compare these two closest regions to the coast. For this one, close to 1 for both the correlation. The error is a bit better for Samosa Plus. And you can see the amount of data included in this analysis for Samosa Plus and for ELS Plus R. Of course, the more you get closer to the coast, the more the contamination increases, and so you have a reduction in the usable data. When you apply the misfit, you want to include just the results that, according to the tracker, are reliable, and you see that Samosa Plus loses a lot of data when the misfit is applied, while ELS Plus R is more robust in this sense, in both regions closer to the coast. And this is an analysis that you want to do when you develop a new tracker because it's important also this aspect. You see here that in the end, for this region, the results are pretty much aligned. And for the last one, Samosa provide better results, but with just 17 points, which is not good. ELS is able providing a way increased data set. Then another discussion could be made on the fact that the misfit is in Samosa Plus evaluated over the full waveform. And so actually, sometimes you have a waveform which is perfectly retracted, and the misfit tells you to take off this waveform, while you have just a small amount of contamination in the trailing edge. And so it's important also to understand that the misfit applied over the full waveform, probably it's not the best deal for filtering. In any case, I explained you the processing options in brief, provided you this difference between else plus R and Samosa. By the way, in the options, sorry, else plus R can be selected here. Sorry if I didn't point this out in the previous discussion. There is a flag that you can activate, and you will get an HCDF file with else plus estimates. And this is it. So once you launch your processing after having selected the processing options, you will be redirected to your home page. You will have the processing hours allocated to you. And then you will see here the processor you are using, Salvatore for Sentinel-3, the name of the task, identification for the console team, the status, and other information. If the task has failed for some reason, sometimes maybe you apply the fully focused R and you just select a very short extent in a long track. And this is not possible because the processor needs a higher extension and you have a failed task. For Sentinel-3 and Cryosat2, it might happen for other reasons. But in any case, every time you have a fail, you ask their console team to support you. If the task ends correctly, green result, you can get to the I button here, enter, you will see the input data, the parameters you have applied, the logs. If there is an issue with the processor, maybe you can check the logs to partially understand the issue. Don't know if it will be clear enough for you, but for the Earth console team, it will allow solving the point for sure. And then the outputs will be available for 2 months since the task termination. So remember to just download the data, and this will be the L1B files and the L2. In particular, you can decide if you want to include the stack data as well. You can decide if you want to include the L1B waveforms as well. So this shall be done in the options that you select before launching the processor. Important is that the output file is an etcdf file, a KML file like those I showed you during the Typhoon Maria discussion, and then a JPEG file with the radargram, like those we have discussed with the coastal zone open loop and closed loop, and then a flag for the water and the land. And this is it. If you want to use Salvatore in Brat, as Brat was not conceived to work with Salvatore products, you have just to access these aliases XML file in the bin directory of Brat and change the latitude to latitude 1 Hz and the longitude to longitude 1 Hz, the time also, in this descriptor, in the section of the file related to the generic NetCDF variant 1. So once done, the track will be displayed in Brat, and you can also process the Salvatore data faster in Brat. I think I can close now the discussion with a brief discussion on how to access Cryosat2 and Sentinel-3 altimetry data. For Cryosat2, please, yes? No, not yet. I think I'm ending this part, and then because the access will be discussed for Sentinel-6 by, okay. So for the ESA data, I'm just providing these slides, and Cryosat2 data can be accessed here. I'm pretty sure Francesco will discuss the Cryotempo products during the workshop. So you have a suite of processors for Cryosat from the ice processor or the ocean processor. You can check for more information in the data description document. And also the Cryotempo are specifically tailored for the scenario of interest. So these are advanced products for the Cryotempo project, and more information will be provided. Now you can download the KML file from this link, and the direct access to the products is done via this FTP, the science server, and you can find the information reported here and at this link, which are basically the same. Some words about the Sentinel-3 data access. Sentinel-3 is joint between ESA and EUMETSAT. The products are distributed accordingly. So EUMETSAT distributes water products covering the ocean and the coastal zone, ESA, coastal zone and inland water areas, including also ice regions. You find all levels, L1A used as input for SAR, L1B after the SAR has been done, and L2 final products with the geophysical estimates. The KML orbit files reported at the beginning of the talk this morning can be downloaded from here to make your investigations, and the access to ESA is on this at this link. You can select if you want a specific sanctioning period. You can select here the interval. Of course, you have to register, and then you have to select the platform, the timeliness of the processing. Again, near real time is about 4 hours after the observation, short time critical 48 hours after the observation, non-time critical with the best orbits after 1 month. Then product level, then the instrument, in our case is RAL, and then you find the products. L1BS is with the stack, L1A is for SAR, and L2 is the LAN. For the LAN products is for the inland water. And once you select the time coverage, select the platform, like done in the previous slide, you can access all the tracks in your region of interest, and you can select the tracks that you want. For EUMETSAT, it works more or less the same. You have to access this website. You will have the product portfolio reported here. And then you can access the data after having read the description, associated description. And once you access, you will have a similar menu. Of course, you have to register again. And then you can select the sensing time range, and just the tracks will be displayed on website on the map. You can select the products that you want, and then you can conclude and download the products. I think I ended the talk. Thanks a lot. And if you have any questions, I'm happy to reply.
Yeah, I wondered if you had questions on the Earth console. When he finished the Earth console, Marco is producing some dense output on these subjects. So do you have any questions on the Brad Toolbox or on the ESA Altimetry Virtual Lab? You come to the microphone. Thank you.
Hi.
Come here and ask your question.
My question is, what is the difference between the options for inland water bodies and coastal with data?
Actually, in inland water, probably you want to use the trackers you can use both Samosa Plus and Samosa Plus Plus for both scenarios. So for the trackers, you can test both. For the inland water, I think one of the advanced options is the fact that you can extend the range window by a factor of 4. And so when you have significant variation in the slope for the hilly areas, this can be very useful. The Hemming should be used in both because you have for both the contamination, the FFT, the zero padding is used usually because improve the retracking, the fitting for both. So I would say it's mostly about selecting the best retrackers because Samosa 2 will not work as Samosa Plus and Samosa Plus Plus for sure. Samosa Plus Plus sometimes works way better than Samosa Plus, but it's really scenario dependent. So maybe you want to have 2 runs to select the best. And I think I didn't highlight during the discussion of the Air Console graphical user interface is that if you want to change just one parameter, like for instance the retracker, I think you can do is that you avoid when you are here, you have processed the data with one retracker. You enter just this menu by clicking on this pencil. You can modify one option to select the other retracker, and you simply resubmit the task without having to go back to the beginning, redesign the bounding box, and so on. So it's quite fast. You just rename it, Samosa Plus or Samosa Plus Plus, and
Yeah, let me add that we have menus. So you enter and you don't know all these 60 parameters that you can choose from.
yes.
And so you can choose the coastal zone menu. So it's all configured with what we think is the best way to process in coastal zone. And you can have access, of course, to the parameters. So you see what they are. Same thing for inland water. So we have a generic inland water custom menu. So you just click on one button and it sets all the parameters by this default for you. Then you can change the parameter by doing this loop very quickly, taking a first run and then modifying and then you look at the differences and so on.
And two things that could be added is that I discussed just the options in relation to Salvatore for Sentinel-3 and Creosat2, these two. But as said, we have also the FFSR processors by Aresis. And so if you're studying the inland water domain, try to have a look because there the posting rate is way higher than 80 Hz. Okay, you can have 100 Hz, 200 Hz, 500 Hz, and so on. The only issue is that, as highlighted by Samira, there is this replica problem. And so if you have a canal, like a very sharp, the issue will not be so big or will be absent. But if you have a lake of a medium size or a normal lake, you will have this mixing of the replicas with the actual signal. And you can make the analysis, but it will be noisier, I think, and less reliable in the best case. Okay, let's say. The only thing with this processor by Aresis is that we don't have the Samosa plus and plus for them because the model actually changes because of the operative mode. So it's something that we have to improve in the future of Air Console. And this is one point. About the other point is that the processor developed by CLS can be downloaded on GitHub, and there is this link in our poster. Okay, so if you want to start looking at FFSR data, you don't even have to go to Earth Console. Okay, you can download the SMAP tool on your PC using it in Python, and you can familiarize with the options, and the retrackers will be, I think, empirical, like with the multi-peak retracker, which multi-peak is physical, and then we have also the threshold peak retracker, which is empirical. So we have two flavors of retracker, and so you can start playing with the fully focused SAR. Then when you are sure about the parameters, you can move to GPod and maybe use the Aresis Omega K, which is way faster in producing the results, and maybe you can start like this your analysis. Okay, and we would like to have the Sentinel-6 data injected in this Aresis FFSR processor in order to allow the people to have the best data for fully focused SAR without this replica problem, or with this replica problem way reduced, no? As explained by Samira. Because the chronogram is way better, you don't have this replication, these replicas in Sentinel-6, they are just of less, having a less impact. So in the future, we plan to extend the Aresis software by injecting the Sentinel-6 data, at least for the coastal zone and inland water. So for just small portions of tracks, because the processing is in any way to be tuned and optimized also for Sentinel-6. Okay.
Yeah, Luciana, can you speak on the microphone so we hear you in the recording?
That you will have the CLS
Yes.
fully focus in.
I explain. Yeah, it's we have it, but we are finalizing the validation of it.
Do you have both versions?
No, no. At the moment, the CLS was developed for the user only in the form of back projection. Plus, they have the Omega K, but I think it's not available to users because in this project, I think they were just asked to develop a fully focused processing in one flavor. So in the end, they decided for the back projection, if I'm correct. Yeah.
So only the back projection.
Yeah, but in any case, sorry if I interrupt you. If you have to process just the data over a canal, over a river, or over a lake, there is a time difference, but it's not as significant as in processing a coastal area of kilometers. Okay. So in any case, you will have the data. I made this for Morocco reservoirs, and processing one track took maybe 10 minutes. I don't know. It was not the end of the world.
So we work with the CLS Python code, and we processed a region of I think on the Rhine, 100 kilometers, and it took 1.5 hours to process these things in our computer. Then we tried to use the computer from the supercomputer. So we have supplied the things and so on. So in my Mac it took half an hour, but normally 1 hour. So it means that if there is a chance to use the other that gives the same, sure. So it would be much more if you have to process. So it took time.
No, okay. Yeah? The point is taken for sure.
So I will have a result on the Elbe, and this is longer. So 3 hours, I think it took. So,
but imagine that this is for free in any case. Okay, sorry? So this is for free. This processor is given to the community for free on GitHub. Okay, on GPod, on Air Console. Sorry, in the team of the Virtual Lab, you have the Aresis processor for Sentinel-3 and Creosat2 in the Omega K form, and these are very fast. So take this GitHub code as something for you to learn about the fully focused R. And, it's
Okay,
like
the question was is only we will have also only the backscatter or also the other one.
for the air console, you already have the
Both.
Omega K,
Okay.
with RSS, but of course it's not for free. You have to request again
Yeah.
from the node. It's already there. We just want to extend it to Sentinel-6.
Okay, and the CLS also will be with all.
CNS will be provided. I think we are just waiting for some validation results from a project, and then we will have this back projection. But in this case, Gbot will be useful only to download the data very quickly, because the issue that you have with Sentinel-3 data is that you have to download the full track from pole to pole, the L1A track, and so it takes 2 gigas. It's a file of 2 gigas every time, even if you want to process a small part of it. Okay.
No,
So
sorry, I just asked if we if the two track do system will be there. No, the CLS
the system
only
will be there.
Okay.
Okay, for sure. But what I told you is that the issue that you have been using as map now is that also that you have to download the full product from ESA, like the L1A from pole to pole, which is a 2 giga file. If ESA would modify the Copernicus access to allow you to extract just the portion that you need of a river or a lake, this would be even faster, okay? Because instead of downloading 2 gigas of L1A file every time, you would download just a few hundreds of megabytes, no? I think. And so this is a thing we have remarked during the Sentinel validation team meeting, and probably they will change the situation in the future. But the processor will be all available in Gbot. The CLS and the RSS in the future you will
with the
find.
two version, both with the two version.
Yes.
Okay.
Okay, I think we should move on. We have now 3 presentations. Thank you very much, Marco, and I think you deserve a round of applause. I don't know how he does that. He speaks like a radio speaker talking about football. You know, he has to say everything at the same time. Well done, Marco. Thank you. So we have 3 presentations now on data access. One by Vankar Rosmorduc. Then we're going to talk about the ESA Climate Change Initiative Sea Level in the coastal phase by Lancelot Leclerc. And then Baltic Sea data set that was created with the Baltic Seal contract. And so there's 3 presentations of 15 minutes, and then we can break for lunch, but we're not too much in a hurry. So please, Banka.
Good morning, everybody, or good afternoon, I don't know. I'm going to talk a little bit about the access to Sentinel-6 data from EUMETSAT. In fact, it's relevant also to Sentinel-3 data from the same data center. So just a few words on the role of EUMETSAT in altimetry. So EUMETSAT operates Sentinel-3A and B and Sentinel-6 and provides their data streams only from marine areas for Sentinel-3, as Marco just said. And also for Sentinel-3, the ocean color and altimetry product, and in real time, short time critical and non-time critical for the operational and the reprocessed data, level 1, 2, and also 2+ and 3 for altimetry. And also a contributing mission from Copernicus, such as JSON 3, 2, and a little bit of SARAL and things like that. The Copernicus data stream is also working with OSISAF and other mandatory EUMETSAT missions, and also with other Copernicus services like the Marine Copernicus, also known as CMEMS, with GMES in Africa, and it's also one of the organizations working behind the WITIO DIAS. So the EUMETSAT user support and training service, whoa, there's a problem of fonts here. The service offer user support and training with regular notification, online technical information, and also an extensive training portfolio. For Copernicus marine data, the focus is on the user community and those working with level 1 and 2 data, such as agencies providing downstream product, commercial entities, and academic users. So the different data types and delivery methods, we've got operational product served through an SFTP server with a 7-day rolling archive, which is not optimal for altimetry, I know. There's a data center with a full mission and offline ordering, and there's also the data store with full reprocessing available and an API access. This is more or less what Marcos showed you screenshots of. And there's an access credential, but you just need to register. And you can search by track number, by cycle number, by time, and other by areas. The API is a Python module you can download called MDAC, and it enables you to access the data through a little bit of Python codes, through search methods like orbit number, path number, cycle number, and the satellite and other product name also, of course. So you've got some bits of codes, and I'm afraid there was a link that is not showing, but it's also here. You've got a knowledge base for each service. So, and a registration. So here I just want to talk a little bit more about Friday afternoon. I don't know if you noticed, but there's a 2-hour training session on Sentinel-6 on Friday afternoon. So we will put a paper for you to confirm your registration at the welcoming desk. Here it is. And if you could register to this eoportal.umetsat.ent in advance so that you will be able to use the data access services. Because what I wanted to do on this afternoon is to make something really interactive and with you manipulating. So if you don't have access to the data, it will be a bit harder. So if you don't want just to look at me clicking on a Jupyter notebook, please register. It's quite easy, and it doesn't send you any spam or anything. So to contact the EUMETSAT help desk, you've got ops@eumetsat.ent. You've got a full training Moodle service at training.eumetsat.ent, and including on Sentinel-6, except I've got a problem here with the fonts. So including on Sentinel-6, if you bear listening at me for a full hour talking on Sentinel-6, you've got this record of short course done late September. So with a number of information on Sentinel-6 in general and on Sentinel-6 at EUMETSAT. You've got also notebook examples which are available for free on GitLab. So it's gitlab.eumetsat.ent/eumetlab. So it's free and open, so you can go there and access it. And especially you've got the ocean part where you'll find some specific notebook for each data stream, each sensor, the different altimeters, but also OLG and SLRGS, well, the SSD sensor on both Sentinel-3. And I'm planning on Friday to have a look at one of those notebook in details. So for Friday's session, as I said, please register on the help desk and register to UMetSat data access so that we can test how to use the Python API. We will look at a notebook available on the GitLab, which is a little way of fetching some data, plotting them. And it can work through binders. So if you don't have Python installed on your laptop, it can work without. If you have it, you've got a list of modules on the GitLab, UMetLab, Learn Sentinel-6 folder. You've got the whole list of modules, including the UMDAC 1, which enable you to access the different Sentinel-6 and 3 data through Python code. So that was about all for today. I hope to see you on Friday. And we will see if there's more than 25 persons. We will see if we can organize a remote. And if you've got questions in the meantime, I'll be around.
Thank you, Vanka. So the requirement from UMetSat was to have a class of 25 people, and 85 people registered. And so what we're going to do is that you have to re-register if you're extremely motivated. You have your laptop, the battery is full, it can last at least 2 hours. You have connected to UMetSat, you have made a login, you have Python, you have containers, you have binders, you have everything.
You don't have to
You're young.
To connect to a website using binder.
You're young, and it has to be gender equality because we cannot go forward in time without this concept. And so re-register. Then we will transmit the whole show in this room because it will take place in a smaller room. And so we will transmit the whole show. So if you want to attend what is going to happen, we will find a way to at least show what Vanka is doing. And you can spend the afternoon in 2 hours after lunch in this room. Okay, that's the way it goes. So I think the best way is to register to the help desk, and it's going to be the first 25. Okay, thank you very much, Vanka. The next talk is by Lancelot, right? Yes. Bonjour, Lancelot. Nice to meet you for the first time. Lancelot is new to the business, working at Lagos with Annie Cazenave in the climate change CCI. He took the place of Yvan Gouznès, if you remember, or if you read his paper. And so you have 15 minutes. And what I suggest, Julius, is that we do your talk after the lunch, because the cafeteria will be upset with us. You're doing you'll tell him, okay. Yeah. Okay, thank you.
So thank you. I'm very happy to be here, and I'm going to present you the ESA Climate Change Initiative Coastal Silver Dataset. So we'll begin with a little word about the data processing. After that, we will see what are the studied regions. And after that, I will introduce you the concept of virtual coastal altimetry station. And we will see how to access the data and a little bit of data visualization. So we have a big question. Is coastal sea level rising at the same rate as in the open ocean? So the objective is to long track the data from JSON altimetry mission. And there is two main parts, the retracking of radar waveforms and the improvement on geophysical collection. So the retracking of radar waveforms is made with the use of ALES, the adaptive leading edge subwaveform from Passaro et al., and is associated C-state BS. And we use the X-track processing system developed at Lagos, who try to improve the geophysical collection. So we reproduced JSON 1, 2, and 3, and we have a resolution of 20 Hertz, so it's around 350 meters between 2 points. We have a temporal coverage of 18 years, from June 2022 to January 2020. And we select the valid data between 0 and 20 kilometers from the coast at numerous coastal sites. So there is a strict editing with performed in order to remove the outliers. So it's based on the trend zero, the percent of missing data, and the continuity between 2 successive points. So a little word about the ALES tracker. So we have seen before, but to avoid the problem of noise in the trailing edge, we try to reconstruct the leading edge. And with that, we can have the seawater height. After that, we use the extract system. So it's applied several data editing. So first part is to try to make a better editing of the geophysical correction, so ionospheric, C-state BS, etc. And the second part is to try to make a better correction of regional with regional model, so from the DAC and the tide correction. And finally, we compute the mean sea surface height and the sea level anomaly along the track, and we have our product who is getting out. After that, there is a final editing. So for each time the track is crossing the land, we create a portion, and we compute the mean by months for the sea level anomaly. We deseasonalize the signal, and we calculate the trend with linear regression. So we have a large coverage of around all the planet, the coast of the planet, as you can see in the red polygons. So this is a long track product. On the figure, you can see the example around the Europe coast, and we can see the cut is the same as the polygon because there is only those data. So the concept of virtual coastal altimetry station. So we, for each track we cross the land, we create a virtual coastal altimetry station. So the dots represent the location of the virtual coastal station, and the associated colors indicate the closest distance to the coast. We have 756 virtual stations at less than 6 kilometers from the coast, and 271 virtual stations at less than 3.5 kilometers from the coast. And you can find all the more information in the paper from Cazenave et al. So we have the local trends, and on the left you have the map with the sites on the associated tracks, and on the right the silver trend at the site. So we choose to illustrate three kinds of trends: the stable one in the first graphs, and an increasing trend in the second one, and a decreasing trend in the third one. So the question is how to access the data. So the data are on the CNO website. So you have the link just behind. And the product and the processing are described in the literature. So yes, the site is here, and you have first part with a lot of information about the team, and after that to explain how the data are processing, etc. And on the second part of the site, you have the three version. So you have to use the last version, and that's it. So the most important information about the products are in the product user guide. And we have three versions. So the first version was uploaded in November 2020. And after that, there was a temporary extension up to December 2019, and the addition of American coast and some region around Africa. And the new version of January 2023, there is a correction of an error in the computation of the direct topographic correction at some sites. So it was it affects 10% of the 756 petrol stations. And there is also an improvement in the intermission bias calculation. So about the visualization, the data are in netcdf format. And you can see the file name, and you have in the file name the region where the data are, the track number, and the site number. So an easy method to look at the header, for example, on Linux system is ncdump with the file name. And I will show you a few examples in the notebook. So I use X-Array with very powerful to open the netcdf files. And I will show you what we have in the data. So we have our variables, the distance to code, the latitude, longitude, time, the local trend and the local trend error associated, and the sea level anomaly for each point. The trends are for each point, and the sea level anomaly are monthly variable. And we have a lot of attributes to describe the data. So you can see many things. We have so important things. The pass number is the track number. The site number is the site, the number of the site, because each time the track crosses the land, we cut the track in portion. So I import. After that, it's just a little bit of visualization, a little map where is the site. We visualize the trend. So we have the raw data, and I put a little filter on those one. And the sea level anomaly, the same. We can have the sea level, and the trend is already computed for them. So that's it. Thank you.
Thank you very much, Lancelot. I think we're just in time for lunch, so Julius will do your talk when we come back from lunch. So if you want to have lunch, if you go down the stairs and you turn right, you have the cafeteria. And there's nice things on the menu I saw. I could not translate everything, but it was quite appealing. And of course, you can go in the neighborhood, find some tapas and so on. And so the idea is that we should reconvene in about an hour. So it might not be too long to get food. We'll see how it works. It's the first day, so just bear with us. And if necessary, we'll start at 10 minutes after 2 instead of 2 sharp. But let's try to be here at 2 o'clock so we can resume. Thank you very much. Have a good lunch break. Can you stop the recording?